Ong Pio Choi from Samsung Electronics, and Madhuka Budugavi and Rajan Joshi from Samsung Research America. They're here to tell you more about Samsung's advanced professional video codec for prosumers that do not want to compromise on quality while capturing video from their smartphone. Let's hear it for them, everyone. How you doing?
Thanks. Thanks a lot. Good afternoon. Well, this session will show advanced professional video codec, APB for short name. Samsung APB codec is a new video codec for users who don't want to compromise on quality while enjoying the convenience of video capturing by smartphone. This codec was developed to address the unique needs of the growing ecosystem for cinematic quality video recording and post-production. In this session, we will present an overview of technologies incorporated in the APB codec and describe its versatile features. Here is an overview of our presentation. Before going into the details of the APB codec, we will first talk about what we mean by professional video. We will then discuss why we need the APB codec. Next, we will describe the details of the APB codec. And finally, we will conclude this talk by discussing benefit of the APB codec. So, what is professional video? Professional video is typically a video captured by cinematic cameras. It has a cinematic quality and is suitable for post-production, editing, color grading, and so on. After post-production, it is coded by conventional video codec like H.264 or HVC, and so on, and then distributed to streaming media or social media, as you know. In contrast, casual video is one most familiar with. We pull out just our smartphone and take video of special events, traveling destinations, or selfies. And then we share to our family and friends. The video codec used for casual video is just the video codec on the smartphone. The captured video is on the smartphone can be readily to share, but it is very hardly to edit. That is problem. This slide compares the visual quality of casual video versus professional video. The visual quality on the left side is typical quality of casual video. It has been coded by HVC. But the visual quality on the right side is the quality we see in professional video, and we can zoom in to see the details. We can see left side has some visual artifact. Yeah, and then I'd like to invite Rajan to talk about why we need the APB codec. Rajan.
Thanks, Kivi. So I'm here to talk about why we need APB, or professional video codec. So right now in the market, there are two trends that are taking place. One is that smartphone cameras are improving in quality So now you can capture high quality content under different light conditions, for example, nightography, or you can have 100x zoom, for example. The other trend that is happening is that there are increasing number of one-person creators or influencers or prosumers. They desire high-quality professional video from their smartphones. So they want to have the convenience of having a smartphone so that they, at a moment's notice, they are able to whip it out of their pockets or purses and capture video. They want a low-cost solution. And they also want to be able to operate under harsh conditions, maybe different lighting conditions, rain, dust, and stuff like that. Now, what is the issue with the existing smartphone codecs? So these codecs are mainly meant for streaming, sharing, and those sort of use cases in mind. But they are not very easy to edit, because when these codecs use multiple frames to basically, there is dependency between frames. So it's not really that easy to edit these videos that the smartphones capture. And the other reason is that the throughput that is required is not really there with the existing smartphone video codecs, because you cannot really drive it above a particular megabits per second. And that can in turn compromise the quality that you are able to achieve with the smartphone, existing smartphone video codecs. And so what we need is a perceptually lossless, low complexity, high throughput codec. And that's why we came up with the APV codec to satisfy those requirements. So what is the APV codec? So an APV codec will sit essentially, so whenever you capture your high quality professional video from your smartphone, it will be using APV codec. And then that can be fed to post-production, existing post-production tools, workflows. And then from there, you can compress them using existing standardized codecs like H.264, HEVC, AV1, et cetera, to share and distribute. So essentially, you will be able to capture the video and then use existing tools for post-production and existing workflows to edit those videos and create cinematic quality video. And then you can further process it and then do other things to share and distribute. So this is kind of a block diagram of the APV codec. So we have, this is essentially an intra-frame only codec. So each frame is coded independently. So what it allows you is easy access to any frame for editing purposes. So you may want to drop some frames, bring in some other content to create a different video. And all those things are very easy because of the intra-only nature of the codec. And then it has 5 blocks, and these are very typical blocks in block-based codecs, traditional block-based codecs. So one is partitioning, then transform, quantization, prediction, and entropy coding. So I'll go through some of these blocks one by one. So the APV codec allows you to partition a frame into tiles and then macro blocks. So each tile can be encoded and decoded independent. So what this allows is parallel processing. So for example, if you are working on a desktop computer or on a cloud computer, and you have many cores available, then you could use those cores in parallel and have a higher throughput. And then furthermore, the tile is then partitioned into something called macro blocks. Then for transform and quantization, so the transform that is used, so each macro block is a 16 by 16 block, and that gets further divided into 8 by 8. And the transform is a two-dimensional discrete cosine transform of size 8 by 8. And quantization is a simple uniform scalar quantization. You can think of it as just doing integerization. So one of the nice properties of this particular transform is that all the energy, once you transform the block, so you'll see that on the left-hand side, there are some values. Those are the luminance values typically. And when you transform it, all the energy is concentrated in very few coefficients, and the rest of them are 0. So when you get these runs of zeros, you can code them very efficiently. Then this is followed by a prediction in the transform domain. And we did that so that the throughput is maintained. You don't have to go back, do an inverse transform to go back to the spatial domain. So this prediction is just a DC transform. So you'll see a blue block and a yellow block. So for the blue block, maybe the DC is 135 and the yellow block is 131. So you just predict, you take the difference and code that instead of coding the big 131 value. So the next thing is high throughput entropy coding. So once you have transformed your block, what you're left with is something, after quantization, you're left with something that is shown on the left bottom part of the slide. And so you go through that block in a zigzag manner. So if you follow the red sort of arrows, so you will go from 3 to 0 to 5, then -1, and so on. So you traverse through the block in a zigzag manner, and then you have a non-zero value and a runs of 0. So what happens is usually you'll get a number of runs of zeros which you can encode in one go without having to encode each coefficient separately, and this increases your throughput. And then finally, a simplified VLC is used to maintain this throughput, but at the same time get nice compression. So now I think my colleague, I would like to invite Madhukar to talk about the benefits of the APV codec.
Good job. Okay, thanks, Rajan. So I'll be talking about the benefits of the APV codec and also showing some visual comparison results, and that's the way we basically evaluate a codec. So to summarize, KP and Rajan, have covered quite a bit of this, but just to reiterate, what are the benefits and what are the features of APV codec? Perceptually lossless video quality. This is very important for video editing purposes. It's a low complexity codec. That is critical because we want to implement it on a smartphone. It is an intra-frame only codec. Like Rajan mentioned, it's useful for editing purposes. Increased chroma fidelity, because we want the colors to be really vibrant when we look at it during post-processing, during production. Frame tiling, high throughput processing, both of these things are needed to basically increase the throughput on a platform, because you will want to do 4K, 8K, 60 frames per second, for example, on a desktop PC, which has multi-cores. So these things will help you to basically increase the throughput. We support bit rates from few hundred megabits per second to a few gigabits per second, different resolutions, 2K, 4K, 8K. The next item is also very important for post-production purposes. This codec does not suffer visual quality degradation when you do multiple iterations of encoding and decoding. Now, why would you do multiple iterations of encoding and decoding? Because you have a really high quality master. You're going to take it, you're going to post-process it. And once it's post-processed, you might want to put your own color tint on it or any kind of other post-processing. You do that. And then finally, that modified master content, you will re-encode it for distribution. So that's the first level of encoding. And depending on your pipeline, you can have multiple levels of encoding. Now, when you do an encode and a decode, it's a lossy process. So quality is lost with a traditional codec. But with APV, the quality degradation is minimal. And that's an important thing for professional video codec. And also, metadata support and all, I won't go into that. So that's, just to reiterate, what are the benefits of basically using the APV codec. Now, of course, it's a new codec. So the, a question to ask is, what is the benefit of this in terms of visual quality? So what we did is we did a subjective evaluation, basically, of APV codec. So the next few slides basically show the subjective evaluation. So we have compared it with two other codecs. APV codec, which is a professional video codec. We have compared it with a conventional professional video codec to see the performance. The second one is APV codec. We are comparing it with HEVC codec. HEVC codec is a proxy for a codec that runs on a smartphone. So we are comparing APV with a professional quality video codec, and we are comparing it to APV with an existing smartphone codec. So in the next two slides, the left side will be the quality that is shown by a conventional professional video codec. And the right side is the quality shown by advanced professional video codec. So we have taken a high quality source, we have compressed it and decompressed it, and the decompressed video we are showing. Okay, so I'll just give a minute for this video to play out. Okay, so just a show of hands, do you guys see any difference in visual quality between the left side and the right side? Who thinks the left is better than the right? Nobody. Who thinks the right is better than the left? Ah, wow, okay, pleasant surprise. Okay, so the right quality is advanced professional video codec. I was about to say that the quality is same for both. In my eyes, at least it was, but looks like, based on a bigger population, the answer is different. So the left video, the conventional professional video codec has been coded at 1.5 gigabits per second, whereas the right codec has been coded at 1.2 gigabits per second. The left is 1.5 conventional, and the right is 1.2 gigabits per second. So there is a 20% bitrate difference, basically. So the right side is taking 20% less bits at roughly the same quality, but the audience has spoken, so maybe the right quality is slightly better than the left, so that's good to know. So this is one example. Let's look at another example. So the bit rates are similar here. The left bit rate is 1.5 gigabits per second for a conventional professional video codec, and the bit rate on the right is 1.2 gigabits per second. Again, a 20% reduction, basically. So I'll just stop talking, and you guys can look at it for a minute. Okay. So again, another show of hands. Is the left better than the right? What about the right better than the left? Okay, I guess everybody in the room got smart. The intention here was to show that the left and the right quality is similar, but the bitrate savings is around 20%, basically. Now, the second comparison is also important. So on the left side, we have a video encoded by HEVC. I'll come into the details. Then on the right side, we have advanced professional video codec. So let's watch it for a minute. Okay, so I'll ask the same question. So who thinks the video quality on the right is better than on the left? Okay, yeah. I think on the left side, you can see, at least when it zooms up, you can see a lot of flickering, blocking artifacts, and so on. But here, the bit rates are different. The bit rate on the left side for HEVC is around 200 megabits per second. And the bit rate on the right is around 1.2 gigabits per second. So is this a fair comparison is a good question to ask, right? So because of throughput issues, HEVC cannot be driven to a gigabits per second on your smartphone. The HEVC iframe can be driven at the most to 200 megabits per second. So that's a representative of really high quality video that you can achieve with existing HEVC that is suitable for post-production, that is using only iframe. The maximum you can go is 200 megabits per second on the left side. And on the right side is the APV codec, which doesn't have that restriction. You can drive it, the bitrate up to multiple gigabits per second. So this is another example. I think here, when you see the zoom region, it will be more obvious. One thing we have to discount is, there is a projector system, which is basically, degrading whatever we show here. So we have a booth here wherein, we are showing this demo on a big screen television. So I encourage everybody, who is seeing this to just go look at it there. This does not really truly give you the true picture, but that would basically, it's a big monitor and you can look at it. So same story. The left side is HEVC iframe coding, and the right side is APV, 200 megabits per second. Again, it's 200 megabits per second because that's the maximum bit rate that we can drive it up to. And this is 1.2 gigabits per second. Here we have no such restriction, and the quality is better. So then the other way to measure codec quality, so far we did the subjective evaluation. This is the easiest, we look at it. Everybody's eye is different, so that's why I polled the room to see, which was better than the other and so on. So that's an easy way to do it, but it's a lot of time consuming. But in video coding research, we use what is called an objective metric. Objective metric is more like a signal to noise ratio kind of a metric. You measure the signal strength, you measure the noise strength, which is, the artifacts, divide one by the other, it comes up with a number. We use a slight variant of that called peak signal to noise ratio. So we can do that, and then we can plot a curve. So if you look at the figures on the left, the bitrate axis is the x-axis. So we have taken APV and we have operated it at different bit rates. And at each bitrate, we are measuring the objective metric. Take 2 frames, throw it in a bunch of math, and you get a peak SNR number, basically. Right? You do the curve, and then you look at the difference between them. At the same quality, so you can draw a horizontal line. At the same quality, how much less bitrate a particular codec is using than the other. That is the metric that we are looking at. Same objective quality. So at the same objective quality, what we noticed is APV compared to the conventional professional video codec requires around 20% less bitrate. So this directly translates into a 20% reduction of storage requirements. So if you have a terabyte phone, that would mean, if you're capturing 1 video per day, then maybe 20% more days you can capture the video without flushing out your phone and memory running out, basically. So that's the advantage. So 20% is a big number. Okay, so now for the conclusions. So one thing is clear. Prosumers want to capture cinematic content on smartphones. Right from my son, anytime he goes, he zooms it up, looks at it, and says, yeah, the quality, I need better quality, better quality, better quality. Because the new generation really wants to do editing. They want to put their own twist. They're not just happy, taking your phone, capturing something and sending it across. They want to put their own twist. Prosumers is another category who want to take the raw video, not raw video, a very high quality video, do some post-processing and then share it. So that thing is clear. They just don't want to compromise the quality. But the convenience of smartphone, nobody can deny it. The whole camera phone business has taken off. And the other regular traditional digital cameras just died very fast because of convenience. I have a phone in my pocket, I pull it out, my son's birthday party or anything, I take a video. So that convenience is there with smartphones. So prosumers want that. They're gone to a really beautiful spot, maybe Grand Canyon, and they have the perfect shot in mind. They don't want to pick up this bulky movie camera and take time to install it, and it's a laborious process. All you want is pull up your phone, shoot, and then go back home, night, whenever, and then you're ready to post-produce it and basically release it to the customer, your customer in the end. So to address this need, Samsung has developed the Advanced Professional Video Codec. So it has been developed to address these unique needs that I was talking about for the growing ecosystem for cinematic quality video recording and post-production. So this is not your traditional casual video, but this is for cinematic quality. And one of the key things is it provides perceptually lossless video quality and consumes 20% less storage compared to existing formats, which is significant number, 20% less. It contains versatile features, high quality video recording, along with ease of real-time editing for professional video coding applications. So APV codec will be appearing on a future smartphone, so please look out for it. And with this, I'd like to end our talk, end this particular session. Thank you for attending this session. Please, again, visit our demo booth, where my colleagues are actually demonstrating the videos that we showed here. You can look at it on your big screen and